Okay, so we're going to be looking at the problem of acid rain. Let me just share my screen here so you can see it. I'm trying to wait for the bell. All right, one of the most serious and widespread problems of acid precipitation in the form of rain, snow, fog, and even dry deposits on particles is acid rain. Now, normal rainwater has a pH of about 5.6, and that's because the carbon dioxide is going to be dissolved in it. And then if the pH of rainwater is below 5.3, then what we do is we call it acid rain. Now, virtually all acid rain is traced back to the burning of fossil fuels in homes, vehicles, power plants, and the processing of mineral oils, or ores, excuse me. Now, the human causes of acid rain. Those major substances that are responsible for acid rain are gases that react with water. So the nonmetal oxide that reacts with water to produce acid is our main component that we're looking at. Coal and oil deposits contain sulfur impurities. Electrical power plants burn these fossil fuels to drive turbines. Sulfur is oxidized to SO2. And here you can see how the sources of sulfur oxides, which are a non-metal oxide, can in fact react with water to produce your acid. So if you take a look at the next page, here, another source of SO2, a non-metal oxide, would be something called smelting, where they extract metals from ores by heating them. The first step is usually going to involve roasting, and that's where the sulfide containing compound is heated to really high temperatures in air. You're going to end up getting sulfur dioxide. And then what'll happen is the weak acid that's produced from the reaction of sulfur dioxide with water would be sulfurous acid, which is unstable, and it doesn't stay in that form. And you're going to end up getting a couple of ions, notably a hydronium ion, which makes it acidic. And rainwater falling through gaseous sulfur dioxide will be more acidic than normal water when it reaches the ground. So it can become worse in polluted air that contains ozone and little tiny fine dust particles. So here they're showing you that when you've got oxygen and ozone together, here's your oxygen, here's your ozone, they will oxidize sulfur dioxide to SO3, which is your product here. Then what happens is your sulfur trioxide is going to react with water to form a strong acid known as sulfuric acid. Then you have 100% ionization of that, which means your rainwater is going to be a lot more acidic than it should be. So when we're referring to SO2 and SO3 in a mixture of gases, they call it SOx, okay? Just like nitrogen monoxide, nitrogen dioxide, nitrogen trioxide is referred to as NOx, And if you're taking any atmospheric chemistry classes, like if you were at Scripps Institution of Oceanography, you'd be talking a lot about this. If you take a look at sources of nitrogen oxides, the air that we breathe is 79% oxygen and 21% oxygen. These two gases will not react with each other normally, but, and that's because the activation energy is just really, really high. But when air is mixed with fossil fuels and burned in a combustion engine of a vehicle or in a power plant, the high temperatures and pressures will cause those substances to react. And when the NO gas encounters the cool outside air, it reacts with oxygen to produce NO2. So the mixture of NO and NO2 in a gas is your NOx. And when you have nitrogen dioxide reacting with water in the atmosphere, you're going to get a strong acid, nitric acid, which will 100% ionize and lead to your acidic rain. Okay. If you take a look at the next page, they've shown you how you've got a summary of the cause and effect of acid rain, your NO2 and your SO2 pollutants moving into the atmosphere, reacting, getting into that cloud water precipitation and coming back down. Let's take a look at the quick check here. It says identify the 3 nonmetal oxides that react with water in the atmosphere to produce acid rain. This is going to be NO2, SO2, SO3. How do coal burning electrical power plants produce sulfur oxide responsible for acid rain? Well, the reaction is this here. So this would be the combustion of impure coal that contains pyrite, produces SO2. Why can the problem of sulfur oxide acid rain become worse in polluted air? Because it contains ozone and fine dust, which we have a lot of here, especially with sunlight, and oxygen and ozone oxidize SO2 and SO3. And that's how we end up getting to our strong acid like sulfuric acid, okay? Now, what are some of the consequences of our acid rain? Well, Scandinavia has a lot of acid rain, and they actually get it from Germany and England and some other countries in Eastern Europe, because that's just the way that the jet stream flows. So if we take a look down here, try to adjust this camera for you. There we go. Southern Ontario and Quebec in Canada receive acid rain that originated from the US, from the industrial belt, from Chicago to Boston. And rainwater with a pH of 2.7, which is about the same as the pH of vinegar, has actually been recorded in Sweden. And a pH of 1.8, which is around the pH for stomach acid, has been recorded from rain in West Virginia. Now, both aquatic and terrestrial ecosystems can be severely affected by acid rain. Most of the species, most of these fish are going to die at pH that is less than 5. And this can actually ruin entire forests. So obviously this is a huge problem. Soils that contain aluminum salts or that are nearly insoluble in groundwater, they'll dissolve when there are acidic conditions. And then it'll release aluminum ions, which are actually toxic to fish. They will also leach nutrients from the soil. And then if you take a look at page 436 here, this is some of the damage caused by acid rain. So a lot of buildings, monuments, cemetery headstones that contain calcium carbonate in the form of marble or limestone, they dissolve in acids. So that's going to damage the structure. As you can see here, this statue has damage from years of exposure to acid rain. Here are trees, soil, water, and fish that can be damaged and destroyed by acid rain. Okay. Now, if we take a look at some reasons for optimism right here. So right here, some lakes in regions where acid rain occurs are naturally protected because they are bounded by soil that is rich in limestone. And when the limestone dissolves, the hydronium ions from the acid rain cause more bicarbonate ions to form. So you could think of it as neutralizing it. So as the bicarbonate ion concentration increases, the lakes have a buffer system to help them maintain a relatively constant pH. Temporary solution, add calcium carbonate or calcium oxide directly to a lake to help it buffer. There are strict emission standards on automobile manufacturers to produce cleaner and more efficient vehicles. Modern vehicles tend to have catalytic converters that reduce levels of carbon monoxide, and they also reduce nitrogen oxides that are burned in the atmosphere. Most major car companies have produced hybrid vehicles so that we can use two other sources of power to move the vehicle. If you take a look at page 437 here, there are electric vehicles like the Volt and the Leaf. Another method for removing sulfur dioxide gas from power plants that are coal-fired would be to use a process called scrubbing. That's where they're going to blow powdered limestone into the combustion chamber where the heat decomposes it to calcium oxide and calcium dioxide. And then another step would be to remove calcium sulfite and unreacted sulfur dioxide and spray it into the exhaust gases before they reach the smokestack to produce a slurry of calcium sulfite. Kind of an expensive process, consumes kind of a lot of energy, but they can bury that calcium sulfite in landfills rather than having it all go into the atmosphere. If you take a look at page 438, where it says acid rain, here it says, write the formula equations for the reactions between each of the three oxides and water that result in the production of the acids responsible for acid rain. Okay, now explain why the release of aluminum ions into the aquatic ecosystems is a serious threat. So in water, aluminum ions hydrate, so they'll be surrounded by water molecules, and they function as weak acids, which means there's going to be hydrogen ions released. And when the hydrogen ions release, then it's going to lower the pH. Okay, this reaction is actually going to look like this. Here is your aluminum surrounded by water molecules. And here are your hydronium ions being released, which is going to affect the pH. Number 3, How does the process of scrubbing remove sulfur dioxide gas from exhaust systems at coal-fired power plants and smelters? Include the relevant chemical equations. So this is where you're going to blow calcium carbonate into the combustion chamber. And it decomposes to calcium oxide and carbon dioxide. So this looks like this. Okay. Then the calcium oxide, which is here, this combines with SO2 to produce calcium sulfite. So that's CaO plus SO2 produces calcium sulfite. Then to remove the CaSO3, they want to add CaO into the exhaust before it reaches the smokestack to produce a slurry, which is then removed.